Okay, so I think I'm recording now. And then here we see, here I did 2 plus 3 plus 4, and I got the answer 9. Here I'm doing 2 plus 3 plus 4.1, and notice that the answer is converted into a real number, 9.1. Here you can also see that here you can change precedence, like how do we get 15 from this? Well, 3 plus 4 is done first, that gives 7. And then here, the multiply is done before the add. So 2 times 7 is 14, plus 1 is 15. And then we can use infix operators like plus, less than, and times, or we can call them using this, sometimes it's called prefix notation, where the function name goes in front. So Jedi 1.0 supports both of those. So here is the class diagram. Now I think we've already have expression and identifier from Jedi 0.0. And so here we're adding a new class called fun call. This is remember expression, that's what the expression is what the user types in. So everything that's to the right of the prompt here is an expression. When the expression gets executed, it produces a value which is printed under the arrow. So under the arrow is a value, and to the right of the arrow is an expression. And all of these expressions that you see here are examples of function calls. And those are internally represented by this fun call class. Did I do it 417 or 411? 417. So I should just get all of these. Oh, all right. So picture what this fun call class looks like. Let's think about it for a moment. So fun call, this arrow here means fun call extends expression. Okay. This arrow here, I call this my has a arrow. A fun call has an operator, which is a type identifier. So in the case of add, that is the operator. Okay, and that's an identifier. Remember, identifier is just a fancy word for name. And then fun call has 0 or more operands, which are of type expression. So here, 2, 3, 4, those are the operands of that fun call. Here, the operands of multiply, this fun call, are themselves fun calls. Okay, so some of you who are a member or CS151 may recognize this as the composite design pattern for a fun call that we're using. Here is a EBNF rule. So a fun call consists of an identifier followed by operands. Okay? Operands consists of a left paren followed by, and then here we have this whole thing, which is optional. That question mark means optional, followed by right paren. So that means that the operands could just be empty parentheses, right? And that's the case for a function that has no inputs. Okay, so then we go inside of this thing. So an expression followed by this thing means that star means 0 or more expressions with commas in front of them. So what this says, putting these rules together into English, is operands is a list of 0 or more comma-separated expressions bracketed by parentheses. And that's exactly what we had up here. Here we have 2 expressions separated by a comma with parentheses around them. Okay. Now you might say, well, what about these guys here? Those are fun calls too, right? And they are fun calls, but it's a trick. Okay. This 2 plus 3 plus 4 is getting compiled. The parser is a parser trick. The parser is going to convert it into this. So by the time it gets to the execute phase, you know, it'll be one of these fun calls. Here's a little note here as well. So Jedi 1.0 is not have user-defined functions. That'll be a feature of Jedi 2.0, the ability to define functions. All of the functions that you can call up here are predefined functions, and those functions are implemented in a component we call the ALU, which stands for Arithmetic and Logic Unit. And that's not different from any other language, even assembly languages. They have to rely on some functions being implemented in the hardware themselves. And usually those functions are arithmetic and logic functions. The piece of hardware that provides them is called the ALU. So we're going to have to create an ALU as well. Here I've created a little test harness that you can use after you've implemented fun call test. So I create an environment, I create a list of operands, and then here I'm going to create a fun call, add with the operands 6 and 7. That's going to be an expression, and then I execute that expression relative to the global environment. So what are we doing? Adding 6 and 7, so you'd expect to see 13 printed there. Okay, let's see. Let's see where to go. Let's scroll down toward the bottom here. So here, I've given you some of the components that you need for this. So why don't you take a minute to start up your Eclipse or IntelliJ and bring up the Jedi that you started for Jedi 0.0. And we can build some of this stuff. We can build some of this stuff together. I'll help you get started on it. So start that up, and then I'm going to do the same. Right. So down here at the bottom, these are all some additional things that have to go into the context, the Jedi context. So let's say a few words about them. First is Jedi exception. I put all of my Jedi exceptions in one class. Let's see, can you, I need to pause for 1 second. I'm having a little crisis here at home. Cat's doing something weird. I'll be right back. Sorry about that. My cat just walked up to me and barfed at my feet. So here is one of the files I've given you. So this is belongs to the context package. Okay, and this is my exception hierarchy for Jedi. And I'm going to see if I have a UML diagram for that. Maybe not, that's fine. I'm going to go over to, let's see. So here is Scala. This is here's my Jedi 0. So I started a project called Jedi. I think you probably did too. Okay, and in Jedi, I've got these expression classes, expression identifier literal. I've got this value class, bool, chars, integer, notification, real, and value. So you should have all of this as well. And here I'm going to add a new Scala class called Jedi Exception.
여보세요?
Yes.
조금? 나 지금 수업하고 있지.
Mignon,
뭔데?
do you have a question? It's not. Oops, sharing the wrong thing. Okay, and so I am just going to paste in all of this code. Okay, so I'm getting some errors here, and I shouldn't get errors, should I? Scala.util, the parsing combinator. Object parsing is not a member of package util. Oh, gee, I wonder if that's some old code there. Let's see, where do I have the right code for that? We were doing some parsing earlier. I think it's down here. Yeah, oh, maybe it's it's the same line. Probably, maybe I have not gotten around to, maybe I haven't gotten around to adding the parser to this parser library. I thought I had, so you'll get to see me do that again. Go to the project and go to properties. I probably should have done this first. Build path. Yeah, there's no parser in here. Add external jars. And here, I think I'm doing 2.12, so I'm going to pick 2.12 here. Okay, my errors have gone away. If you, that reminds me, let me make sure that's the screen I'm showing. That reminds me that if, I should have probably started talking about this first. So if you're having trouble with your parsers, you need to get your parsers working first. I'll show you, I posted a little video and an example, I think yesterday, about parsing in Scala. So you should work through that example and make sure that your parsers are working. Otherwise, you need to come into office hours or something, talk about it. Let's see. So what version? Yeah, version 12 is what I'm using, but you check though for yourself. I mean, I'm using an old version, which I shouldn't be, but I'm too lazy to change it. So I go to properties of the project, and here you can see the Scala library container is version 12 here. So generally what I found is that you want to like choose the parser combinator as close as you can to the library that you're using. So I'm using 12. All right, so this is my hierarchy of exceptions. What I did was I sat down with myself and I thought, okay, what's everything that can go wrong? And I could think of 3 major things that could go wrong. And they're listed here. Undefined exception. So undefined would be if I did something like 3 plus x, but I forgot to say what x is. So, so the kind of exception that I should get is an undefined exception. Another example, a type exception. So that would happen if, for example, the user typed in something like 3 plus hello world. Okay, well, no, that doesn't make sense. You can't add an integer to a string, so that would be a type exception. And then a syntax exception would be if the user typed in something like 3 plus and then nothing after that. So those were those are the main kinds of things that I could think of. And what I did was all of these extend Jedi exception, right? So if there's something that I haven't thought of, well, you can just throw a Jedi exception and you can provide like an error message. I call my error message a gripe. What was the problem? Okay, and this is exception from Scala's exception class. Okay, so I've got customized exception subclasses for the most common kinds of things that can happen. And you'll also get an idea here, just a little recollection. I'll get your questions in a second. Let's see. You see how I initialize these things. So Jedi exception wants a string. Its constructor wants a string as an input. That string is a val. And here, undefined exception, name is not a val or anything. The only reason I have name here is to pass it on to the Jedi exception constructor. Something's going on here, so better take a look at it. Where did I get the external jar? Yeah, so maybe I should say a few words about that. So you can get it online from like the Maven Repository. I think though that, let's see, I think I provided one for you too. Let's see, where would that be? I think maybe when we were talking about, so this is maybe worth taking a moment to discuss. These are the notes, the Scala programming notes, language processors. I think if you scroll down here, blah, 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 blah. All right, so here is a parser combinator library. Let's see which one that is. Right, so it wants to download Scala parser. This is 2.12 that I have here. Cancel that. There are a couple of other links, and I think here if you go to Maven Repository, Scala, there are a bunch of places that you can do So this is actually a great page right here. And so here, for example, if you're running Scala, any of these Scala versions, right, then this is the version of the parser library that you should be using. And these version numbers here, I think, are a little bit different than the version numbers that we're seeing. Okay. Also, the other thing, since I have you here, this is these are the lecture notes, parsing in Scala. If you go to the very bottom of this, Scala parser combinators, an example. So here so I posted a video, not a video. Yeah, I think it is a video actually, of me going through these notes. And this is, I think, probably a much better example of much better tutorial on how to use these Scala parser combinators. So you should go through these examples. So I give a bunch of code in here and make sure that you can get them running. That'll be the test to see if you're that'll be the test to see if your parsers are working. If you've got the right parser library in here. Yeah, I think all of the code is in here that you actually need to build these sum of products. And we can talk about this, although I did give a video. There is like a video. I think I sent a link through the announcements on it. Right. Where was I? Oops, not there. Oops, not there. Well, maybe this is a good place to be. Let's go back to where we were. So, so that's the exceptions that you will be throwing. Next, let's grab this environment guy. Now, I already gave you an environment, and that environment is actually good enough. But this is a more advanced environment that we're going to be using for future versions of Java. So here I'll click on environment. So this is the definition of environment we have. Environment is just a two-column table that associates identifiers named like X, Y, and Z with their corresponding value. So I'm going to paste this guy in, which basically is the same thing. I'm not going to talk about it now, but here's environment, okay? And he extends hash map, just as we had before. But he also has in here a parameter, which is an extension environment, which is default is null, doesn't exist. And so using this extension environment, we'll be able to like chain together several environment tables. So that'll be important, for example, when we're doing function calls in Jedi 2.0. So, you know, I don't know. Here's this. So look over this code and make sure that you understand, although I will talk about that. That code's a little bit complicated. Let's see, what else did I give you? Well, here's the console. We don't have a console yet. Console is the user interface. This goes in the context, and I think it's a lowercase c. So, and this is a Scala object. Check on the spelling of console. Yeah, it's lowercase. So console is, let's see, we don't have those parsers yet, so of course that's going to be a problem. So I want you to use this console. So the heart of the console, the engine that drives it, is REPL. Here, REPL stands for read, execute, print loop. Okay. So while the user has more work to do, you print out a prompt. Okay, you read in what the user types in. CMMD is just going to be a string. If the string is quit, you set more to false. Otherwise, you execute the command. Now, when you execute this command, bad things could happen. And so notice that inside, all of this is inside the while loop, but this is a try block, and it's followed by this catch block. We got a bunch of catch blocks. Why is the formatting weird on those guys? Oh, I see, because they're cases. That the formatting's okay. So maybe executing this command through a syntax exception. So I will catch it here. And more about this a little bit later on, but the exceptions thrown by the parser are really cool exceptions because they tell you, exactly where this the line, column, and token where the thing went wrong. So I'm going to print all of that out for the user. Or maybe there's an undefined exception. So I'll just print out whatever the gripe was. And then I have a verbose flag up here for debugging purposes. It's up here, verbose is just a Boolean flag, which is false. If I set it to true, then you get a stack trace printed out. Okay. There you guys are still working on that. Okay. I'd pretty much do the same for type exception. Jedi exception comes after these. So if it wasn't any of those, maybe it was just a general Jedi exception. And then finally, the last is just some kind of an exception. And here my policy is, well, if it wasn't a Jedi exception, then it must be something that's really wrong. Not wrong necessarily with the code, but I don't know, maybe the computer ran out of memory or something. And so here I've set more equal to false. I say it's time to bail on this thing. So, and then I flush out the console here. Here I'm going to print out a little bye when you finally quit out of this thing. Now, I also have a second version of this, which you don't have to understand, but this guy allows you to write a Jedi program in a file, and it reads in the file. This is how you'll be testing your code with this, like in main, for example. In main, I look at these args that you pass in, the command line arguments. If there's no command line arguments, I call REPL. Otherwise, I call that execute file here. So that'll also be have the greater grades, these things. You don't really need to understand how execute file works unless you want to learn more about doing file processing in Scala. Here's execute. So execute takes this command as an input. This is a string like, add 2, 3, something like that. And it's going to use its parsers, the expression parser, to parse the command. And that's going to produce some kind of, I call it a tree here. Okay. The tree could be a failure, right? In which case that's because there was a syntax exception. Otherwise, the tree, I'm going to get the tree, it's going to be an expression. I will execute the expression in the global environment. Where's that? Here's my global environment right here. Okay, and then I'll convert the result to a string and return it. So that's the whole way the interpreter works. It reads in your command, it parses the command into an expression. Your command is a string, it parses it to an expression, it executes the expression, and then it prints the result, the value that returns. Looks like you guys are still struggling. Some of you are still struggling with the parsers. Yeah, that error message, is it Jacob? That error message you're getting, Jacob, is not usually what happens if it's a problem with the different versions. Like if you don't have the right versions, what happens is it shows an error in the project, and the project doesn't run, but there's no error like in any of the files. So it's a more mysterious looking bug than that. Okay. And then what else? There's our console. And then here is the ALU. So that's also a singleton object. So Scala object, ALU. Now, here is the way my ALU works. Okay, so ALU has this execute method in it. And execute wants two inputs. It wants an identifier, an opcode, the name of the function. And args is a list of values to be combined by the function. And here, for example, if the name of the function, so opcode.name match, I'm using if the name of the opcode is the string add, okay, then I'm going to call add args. And add args is a private function down here that adds it takes a list of values and adds them together. And if this looks complicated, it's because you can add integers, you can add reals, you can add strings together. So add makes sense in all of those contexts. That's why it's so complicated. So this is basically a list of all of the built-in functions: add, multiply, subtract, divide, less, more, equals, unequals, not, write, prompt, read. And the ones with the little errors next to them, those are errors because I didn't implement these functions yet. That's going to be your job to do, to implement these functions. And many of the functions can be implemented by imitating the ones that I have implemented. And so, we'll be talking more. I don't think I really want to get into this right now. We'll talk more about that later. So there you have it. Oh, and then there's the parsers themselves. I think I've given you, this Jedi 1.0 parsers. Click on that. Oh, I see. This is, I think if you go to the bottom, here it is, Jedi 1 parsers.scala. And I don't want to talk about this stuff yet, so that's going to be a little bit later on. Is the screen I'm on? No, this isn't the screen I'm on. Sorry. Here we are back here. Okay, so what I've done is I've loaded these files in. You go to Jedi 1.0 parsers, I give you a little start on the parsers that you also go into the context class. Okay, and there's also a little to-do list here, getting started. Right, so this sort of takes you through. Is this right? This looks more like, what do we need declaration? Oh, we do need declaration. Well, this gives a little checklist of like some of the stuff that you have to do. All right. So So one of your first jobs is going to be to implement this fun call class. Okay, and these arrows show you what fields and what extension it needs. And then fun call has execute in it. And so then you need to execute, you need to implement execute. Let's see if I give you a hint about that here. No, I don't. But basically, fun call execute is just going to call ALU.execute. So, so I guess, do I want to say stuff about that? What have I said here? Oh, here, I've said it here. Funcall.execute begins by eagerly executing all of its operands. Okay, so here are the operands. The operands are expressions, and expressions are things that know how to execute themselves. When you execute an expression, you get a value. Okay, so if you execute all of the operands, we've got a list of operands, you're going to get a list of values. Consider using map for that, operands.map. Okay, so this produces a list of values called arguments. Okay, and then you take that list of arguments and you call ALU.execute. Operator is going to be the same. Add, multiply, whatever it is. And now arguments, instead of being a list of expressions, this is going to be a list of values. And that's what the ALU wants. Okay, so some of you are still struggling with the parser, but let's maybe hold off. Let's see, what time is it? Let's hold off on that for a minute. Let's not worry about that. Make sure that you understand the code that you're going to write here for this fun call. Okay, so step one, fun call.execute. Step one, execute all of these operands, call the result arguments, and then call ALU.execute operator with the arguments. Okay, 2. So take a look at this sample session with Jedi. So here I'm asking 3 less than 4 and 2 equals 1 and x. And it returns false, which is correct. 3 is less than 4, that's true, but 2 equals 1 is false. And so at this point, I know that the whole thing has got to be false. If you're anding together a bunch of things and one of those things is false, then the whole thing is false. Same thing with or. 2 equals 1, that's false. 3 less than 4, that's true, or x. Now, if you're oring together a bunch of things, then if just one of them's true, the whole thing is true. Here is a conditional expression. If 3 is less than 4, then here I'm going to return 3 plus 4, else I'll return x. And this returns 7 because 3 is less than 4. And then finally I say, hey, what was x? And look, x was never defined. How come I didn't see this error message earlier? Well, that's because and, or, and if are special. Okay, they use a different kind of execution algorithm, sometimes called, or it's a form of execution called lazy execution. Lazy execution means execute your, well, let's look at it for and or. The form of lazy execution for and or is called short circuit execution. Short circuit execution means execute your inputs from left to right until you know the answer. As soon as you know your answer, don't stop executing your inputs and tell us what the answer is. So here, 3 less than 4 is true. I still don't know what the answer is going to be. 2 equals 1 is false. Bam, I know what the answer is going to be. The whole thing has got to be false. And I never made it to X here because I didn't have to. And it's called lazy because, to contrast it with eager, like for fun call, all of the inputs are executed whether we need them or not. But lazy, only those guys that we actually need get executed. Here for if, we use what's called conditional execution. So execute the condition. If the condition is true, execute the consequence, but ignore the alternative. If the condition is false, execute the alternative, but ignore the consequence. Either way, not all of the inputs get executed, which is why it's called lazy. Right? We use this all of the time in programming. Here's an example of something that looks like a line from Java, maybe. Okay, so here I'm asking, well, I'm trying to compute the square root of x. Okay, and first of all, I want to make sure x is not null. And if x is an instance of double, and if 0 is less than or equal to x, x is positive, then calculate the square root of x. Now notice that the order of these questions I'm asking is important, right? I mean, so for example, suppose I ask this question first: is x an instance of double? But suppose x is null. If x is null and I try to call a method like this, program's going to crash. Or suppose I ask if 0 is less than or equal to x before I ask if x is a double. And suppose x is not a double, it's, I don't know, maybe a Boolean or something like that, then that'll cause the program to crash. So programmers routinely depend on lazy execution. And without lazy execution, recursion is impossible. Doing error checking your inputs in the right order is impossible. So so laziness is like an essential form of execution. Every programming language needs a little bit of laziness in it. Some languages like Haskell, everything is lazy, and that'll be like an option for Jedi that we'll see. So because these guys are lazy, here's the syntax for condition, conjunction, disjunction. Condition is an expression followed by 0 or more additional expressions with these AND operators in front of them. Here's the syntax for if. Notice that if, the else part is optional. And what happened? Let's see if I've got that here. Oh, we'll see. So here. Yeah, so if the condition is false and there is no alternative, then you're supposed to return notification.unspecified. Here is the diagram, the class diagram. So you've got to turn this into code. Okay, so here's expression. I'm introducing a new trait here called special form that extends expression. Special form is an empty trait. It's just a catch-all for all of those expressions that have weird one-off execute algorithms. And then here's conditional, conjunction, and disjunction. Disjunction are the ors, conjunction are the ands, conditional is the if. Okay, and let's take a look at disjunction. So disjunction is a special form, which means it is an expression. And then it's got this list of 2 or more operands. These are the things that are being ORed together. Conjunction is a special form, which is therefore an expression, and it has a list of 2 or more operands that have to be ANDed together. Conditional is a special form. It has a condition, that's the part that goes in parentheses, and then up here it's got 1 or 2 expressions. The first expression is the consequent, the then part, and the alternative is the else part, which is optional. So you have to take this diagram and convert this diagram into Scala code. Okay, and the tricky part is going to be conditional, conjunction, and disjunction. They all need execute methods in them. Okay, and so for example, for conjunction, execute will be execute my operands from left to right, and as soon as like one of them produces like a value of false, just stop and return false. Otherwise, return true. Also, you have to make sure, you have to do a lot of type checking and execute here, to make sure that all of your operands are bools, have bools for their values. So, what are we doing here? Let's see what questions I've got here. So, Jacob, we'll probably have to talk offline about your problems. So, maybe go through that extended example with the video that I gave to make sure that you can get things working with the parser. Okay. Let's do a little bit more then. The next piece of Jedi 1.0 are declarations. Here's like a sample of declarations. A declaration begins with def, the name that you're introducing, an equal sign, and then here is like an expression, the value of which is going to be the new value here. So I'm defining pi to be 3.14. Notice that the return value here is the notifications. In Jedi 0.0, I made you add these notifications. Look at that. I'll show you that code in a minute. So, this is returning the notification okay. So here my policy is that expressions that produce side effects, and here a declaration produces a side effect of adding like a new row to the environment, adding something, updating the environment. So if an expression produces a side effect, then its return value should just be a notification. Okay, you wouldn't want to return, like, for example, in some languages, like C, when you define something, it returns the value of the thing defined. And I don't like that because I think it encourages programmers to try to use that. And so they might like say something like 3 plus define pi equals to 3.14, right? And I think that's really confusing code, and we should discourage Jedi programmers from doing that sort of thing. We do that by returning notifications, and notifications are, the thing about notifications are that they're useless. Okay, they provide an acknowledgement, yes, some update happened, some side effect happen, but they're not something that you could use. So it's discouraging you from nesting a definition inside of a function call, for example. Here in this example, notice that the right-hand side can be like any kind of an expression at all. Here's the syntax. A declaration consists of the string def, followed by an identifier, followed by an equal sign, followed by an expression. Here's the class diagram. Declaration is also a special form. Okay, it has an expression, that's this part here, and it has an identifier. Here's the identifier here, and then the expression is this part right here. And then you'll need an execute for declaration. Okay, and what declaration is, remember execute, you get the current environment as a parameter to execute. So all you have to do is just add, calculate execute the expression to get the value. And then in the environment, you put this identifier with the value of this expression and you return OK notification. Okay, so right now then, is your to-do list is to step 1, load in all of these classes. Okay. Step 2 maybe would be to implement the fun call class. Step 3, implement special form, which is nothing. Conditional conjunction, disjunction. Step 4, implement declaration. All right, and then I would go to work on this ALU. For right now, you can comment out the lines that are giving you errors. Okay. We'll talk about parsers, I think, next time. You can test some of this stuff. Well, I gave you a test for fun calls. Let's take a look at, here's Jedi Testing. Oops, Jedi tests. We'll talk about that a little bit later on. Let's see how we're doing. Oh, good. All right, let's look at this link here for a moment. This diagram here is another UML diagram. I know it looks pretty crazy. This is called what is this called? A sequence diagram, I think. Okay, and sequence diagram is showing kind of the flow of control through a program. So here we have at the top objects. Okay, here's a console object, a Jedi parsers object. These are some objects. Here's the global environment. Here's the ALU object. And these lines that dangle down below the object are called timelines. So time flows downward in this diagram. And then the arrows that you see, those are messages going back and forth at different times between the objects. It's kind of a cool diagram. Okay. There are several kinds of messages. The most simple kind of message is a function call. So one object is invoking the method of another object, calling another object's method. This dashed arrow is a return value. Okay? There's some other kinds of messages like create messages. This yellow box right here is activation period. So here, for example, let's start this out. So here at the beginning of time, somebody is given the string x+2 to the console. They type that in. And then this is, in Jedi parsers, there's a parser called expression that takes this string x+2 as an input. And this yellow box here then represents the period of time that the parser is active. And here at the end of that period, it's created an expression object. That's what parsers do. They convert strings into expressions. So here's the expression it's created, and it's sending it back to the console. Okay, so here is the string x+2. What did the parser do? Well, it created a fun call object. So exp is a fun call. It also created 2, the integer 2, and the identifier x. So these are all of these classes that we're talking about here. These are all classes in Jedi. And so it put all of these things together and returned them. So exp is the fun call. So it's returning a fun call to the console. Now, the console is going to execute. What happened to exp? Oh, it's going to call. So here's exp again. Okay, exp is a fun call. A fun call is an expression. Expression has an execute method. And so we're calling the execute method of that fun call, and we're providing it with the global environment. So remember, exp is the fun call x+2. Okay, so remember, execute for fun call is eager. It eagerly executes its operands. Its operands are 2 and x. So it's going to execute 2, and here's the value of 2 coming back. It's 2. It's going to execute x, and here I guess, an x as the identifier. He has to go to the global environment and say, hey, what is x? And let's assume that x is defined to be 3. I think, yes, up here x was defined to be 3. So here comes 3 back. So 3 is sent here. And now we're inside funcall.execute. It sends a message off to the ALU that says, please execute. The opcode is add, and the arguments are 2 and 3. This guy actually adds together 2 and 3, and here comes the value 5 back. 5 is then returned to the console, and the console prints 5. And so you can, so that is like the way things flow here. So we first parse whatever the user typed into the console. This gives us an expression. We then execute the expression, which requires executing the sub-expressions, which requires looking things up in the global environment. And if it's a fun call, ultimately requires the help of the ALU. And then the value is returned to the console. So that little diagram, and there are more diagrams, we'll get to those a little bit later on. You're sort of showing, well, this is parsing. We'll talk more about this later on, but these are like little flowchart diagrams that show how all of this stuff fits together, and we're not quite ready to talk about those yet. Okay. So I don't want to quite burden you down with too much here. I've got 5 minutes of your time left, so I think I will go to, let's see, where did I put that? I guess it was in the lecture notes, Scala programming notes. make this link a little more obvious for you. At the bottom here, parser combinator is an example. This was that SOP language, sums of products language. And here I did it two different ways that I did it. This was one version of my parser, right? So again, the way that you do these parsers is, of course, you have to add in the parser library, right? And here you would need to create a little project. I think I've given you expressions.scala. So here is like a expression is just a trait. When you execute it, it produces a double, no environment here. And a sum is got operand 1, that's the first thing to be added, and then operands is a list of expressions. These are additional things that need to be added. And here's how you execute the sum. You execute operand 1, and then you add it to your operands map.execute reduce using plus. So I add together the values of all of these operands and add those to the value of operand 1. Okay, same thing for multiply. So you add that in. And then let's look at these parsers again. Oh, that's the. So here's what I want you to notice. So here's the rule for a sum. A sum is a product followed by, and then this means 0 or more products with plus signs in front of them. So here's how it looks in Scala. Sum is a parser which produces an expression as an output, takes a string as an input, could possibly return a failure of some sort. Okay. Product is already a parser which is defined here. So I'm going to parse the first thing with the product parser, the beginning. And then I don't have star. I don't have this star that we have up here. Instead, star is rep in here. So a repetition of plus sign followed by product. And so that's how you translate that first rule is being translated into Scala with this rule. I mean, they're pretty close to each other. The only difference is that I've got rep instead of star, prefix rep instead of postfix star. And the other thing here is I've got that little arrowhead here, which means check to make sure the plus sign is there, but don't include it in the result. So this parses this thing. And then this means transform by. And now there are two possible outputs. So here's the part that I want you to pay attention to. Rep produces a list of products. Okay, it's possible, because it's 0 or more, it's possible that the list is nil, empty. Okay, in which case, and so this first product, the output of it, I'm calling P. Right, and the output of rep, I'm assuming is a list of products, prods I call it, or possibly nil. So if it's just nil, then I just return P by itself. Otherwise, if it's P followed by a list of more products, then I call the sum constructor, which that's exactly what it wants. It wants a product, and then it wants a list of products. Okay, so if there are no plus signs in it, then the whole thing just devolves to a product. And so rep returns a list. Okay, so try that out. And then I do like another version. And in this version, I'm using OPT instead of rep. OPT, rep means 0 or more. OPT means 0 or 1. Okay, and OPT doesn't return a list, it returns an option. Remember what an option is? And so here in sum, the output of OPT is either none or some. Okay, and so I have a slightly different definition of what the sums and products are here. So that's what I want you to know, is that rep returns a list of expressions, and OPT is going to return an optional expression, either a sum or a none. REP returns either nil or a list. Okay, let's stop sharing for a minute. Are we doing? Do we do Jedi 2.0 as well? Yes. So what's going to happen, Brianna, is that Jedi 3.0 will include subsume Jedi 2.0, right? So you're going to combine both of those things together. Well, the other thing that I want to tell you here is that Jedi 2.0, Jedi 3.0, they're not going to work. And you'll get zeros on those things unless Jedi 1.0 works. So if Jedi 1.0 doesn't work, if you can't get that working, then you're in deep trouble. Okay, so that's why I've extended the deadline for this. Assume that you guys didn't do this stuff over spring break. I've extended the deadline. I forget what it is. I think maybe the 17th. You can look it up on Canvas. It's not extended on the website yet. Because Jedi 1.0 needs to be perfect. You need to have it working. And don't just copy it from somebody. You also need to know how it works, because what I do to you on the final exam is I say, add this feature to Jedi 3.0. And you have to know exactly what code needs to be augmented or enhanced in order to you have to know exactly where to put it. So really, like, the important part of the second half of the course here is like understanding how these language processors work. Any other questions? No? All right. I will talk to you all on Thursday then, and try to get some of this stuff done. See you later. Bye.